Hello everyone. So if you're at home, then enjoy yourselves being at home. If you're at school, hopefully you've already got one of these, which is, I would say, one of the best biscuits ever invented, the ginger crunch cream. Now, the reason for this is we're about to take on Surds, and there's no two ways about it. Surds are tricky beasts, so we need a little bit of a rather tasty sugar boost to kick us off with. And a little challenge goes out to Mrs. Hill for next week to see whether or not, inexpensively, she can come up with a better biscuit. Somehow, I think not. I know Mrs. Muggleston wouldn't manage it because she thinks a rich tea is the best biscuit out there. The least said about that, the better. Right, now, Surds are a tricky little thing, so we're going to start off with something a bit simpler that's going to help us later on. A little game I like to call Finding Factors, Identifying Squares. Catchy title. I'll show you for 20. So you make the factor creature for the number. Always start with 1 in itself, then if 2 goes into it, however many 2's. If 3 goes into it, doesn't, so we go on to 4, and 4 times 5. Now, there's no numbers between 4 and 5. I now know I've found them all. At this point, I'm going to identify the squares. Now, 1 is a square number, they've all got 1. And 4 is the biggest square number there, so I'm going to put a second thing round there. Right, off you go. See if you can do the same process for the other 6 now. Pause it and have a go while I eat my biscuit. Okay, so this is it as far as all of the factors. Then the squares, I'm not going to bother with the ones. 4 is a square number, but so is 16, so that's the biggest one. 25 is your only square number there. You've got 4. You've also got 10. You've also got 25, so that's the biggest one there. 9. 4 and 9. And is that the biggest one? No, because 36 is a square number. In fact, we can say the same for 100, can't we? Okay, that's that game over with. Time to move on to the wonderful world of Surds. Now, the world of Surds was not so wonderful to the poor chap who discovered the first one. He was one of the Pythagoreans, and he pointed out, after Pythagoras had come up with his theorem about a squared plus b squared equals c squared for any square number, that if you had a unit isosceles triangle, so those sides were 1 and 1, what was the length of this? Now that would be the square root of 1 squared plus 1 squared, which is 2, so the square root of 2. And he said, what's the square root of 2? Now, we might all get a bit puzzled about that, but not think it's that bad a thing. But actually, the Pythagoreans, at Pythagoras' request, apparently threw the poor chap off a cliff into the sea, and he died. And the reason they did that was, one of their many beliefs was that everything that held up the world was, if you looked at it closely enough, granular, made up of little things, and you could identify everything down to its last little bit. Now, you can't really do that with the square root of 2, and that was what he asked Pythagoras. He said, how can we do that with the square root of 2? And that really annoyed him. It's 1.4 something, but exactly what it is, we're not sure. Now, to make Surds a little simpler, we like to talk about the smallest Surd that we can find. And we're going to go on to something called simplifying Surds right now. So we might have something like one of those numbers we had before. We had 32, so we might have root 32. Now, one of the rules of Surds is that if you multiply the square roots of any two numbers that go into that number, that will also give you the same square root. So, for example, it is the same thing as root 2 times root 12, but that's not going to help us too much. The thing we're going to be looking for is the biggest square number. Do you remember that we had 4 times 8 and that was square, but we also had 2 times 16 and that's square too. And what we're going to use is root 2 times root 16 will give us the same thing as root 32. And we know what the square root of 16 is, don't we? The square root of 16 is 4, so we can write this as 4 root 2. And that has simplified our surd, because at least in my head somewhere I know it's something somewhere over 1 and it's not as big as 1.5. But I'm really confused when I start thinking about the square root of 32. The other thing is, by doing this, there will be questions, folks, where we manage to get rid of surds altogether. And that's the really clever bit. Right, so I'd now like you to have a go at simplifying the following surds. Okay, so here they are. Pause the video. Whilst you're doing that, I'm going to jolly this up with a little bit of green. So look out for that. Remember, do the factors, find your square numbers. That's the key to getting started. Okay, so this is what you should have. Have a little moment to mark it. You might want to pause it. I'm going to tell you about one, because you may well find that you've done something correct, but you haven't got it in its simplest form quite yet. A little bit like if you had 12 over 24 and you said that's the same as 6 over 12, you're right, but you could go on and you could make that 1 over 2. It is possible that you might not have fully done it yet. So I'm going to do that for this one over here now. So root 72, if you had identified that 72 equals, I don't know, you might have gone for 8 times 9, because 9 is a square number, isn't it? 8 times root 9. The square root of 9 is 3, so that would have given you 3 root 8. But it's not fully simplified, because the factors of 8 are 1 and 8 and 2 times 4, and 4 is a square number. So we could then say that that is going to equal 3 times root 4 times root 2. And the square root of 4 is 2, and 3 times 2 is 6, so that gets us to 6 root 2. So it's not the end of the world if you don't find the biggest square number, as long as you have a look at whatever your surd is and think, has that got another square number still in there as a factor? So look out for that. Okay, so the next thing we're going to do is to rationalise a denominator. Now, what we don't like about surds is they do send people a little insane. We no longer throw people off cliffs for talking about surds, but we do moan at them a bit. So if you rationalise something, you make it sane. And a denominator, that's something we get in a fraction, isn't it? So you might have something like 1 over the square root of 2. Now that's got an irrational denominator, because a surd is not a rational number. So what we have to do to rationalise a denominator is just find an equivalent fraction for it where we haven't got a surd on the bottom, but we can have it in the top. So all we do is multiply top and bottom by the surd that we've got down there. So if I put root 2 over root 2, if I multiply by root 2 divided by root 2 will still be 1. Anything divided by itself is 1. So when I times by that, I'm not changing the meaning of this fraction. So 1 times root 2 is root 2. Root 2 times root 2 is 2, because any root times itself is going to get you there. That's why it's called a root. So that's your example. I'm going to pop a few more down here now and you can pause the video and have a little go at some of those. Enjoy. Okay, so have a go at these ones. Little hint, by the way, when you get to this one here, you only need to multiply top and bottom by root 5. You don't need to worry about all of the denominator, just the surd. Okay, pause the video and have a little go. Okay, so here's the answers have a little look at those, mark them. You might want to pause it whilst you're having a look. I put the working for this one up the top there, and I've put a little bit towards here on the end where you've got to 5 root 10 over 90 you might have done, but you should then spot that 5 goes into 90 18 times. That leaves you root 10 over 18. And I thought I'd go through this little chappy here, because this says root 8 there, and in the answer it says root 2, so that's a little bit awkward. So if we start off with 3 over 4 root 8, the first thing to do is to multiply top and bottom by root 8, and what that gives me is 3 root 8 on the top, and root 8 times 8 is 8, so 4 times 8 is 32. And you may well have got there and stopped there. However, root 8, remember, I'm just going to take this bit out so I've got some space. Root 8 is equal to root 2 times root 4, isn't it? Because 4 is a square number and is a factor of 8. So that's going to give me 2 root 2 right there. So for that reason, I can say that this badger is going to be 3 times 2 root 2 all over 32. 3 2's are 6, so that gives me 6 root 2 over 32. And at that point, the more observant ones amongst you will have noticed that 2 goes 3 times into 6 and 16 times into 32, which gives us that answer we've got down here of 3 root 2 over 16. Okay, and that's just one more little part of the world of surds we're going to go to today. Right, we're going to need a little recap onto something in expanding the brackets. Could you pause the video and have a go at expanding that? You may want to use a little grid before you do so. So you should get x squared, you get minus 3x there, and you get plus 3x there. Negative 3 times 3 is negative 9. When we add the x's together, they disappear, and we get this answer of x squared minus 9. Now, because x squared is a square, and 9 is a square, and when you take one thing from another, you could say you're finding the difference between them. Like, for example, 5 take 4 is 1. The difference between 5 and 4 is 1. This is called the difference, and you may well remember this, between two squares. And this has an application in surds that I'm about to show you that has a knock-on effect when it comes to rationalising a denominator. Okay, so this is the sort of thing you may be faced with. Now, in order to do that, we're going to do something very similar. If instead of thinking of this as root 3, you think, oh, I'd just rather call it the letter x, you could see that as 1 minus x. And we're going to multiply top and bottom by 1 plus root 3. Now, you may be thinking, why the flip are you going to do that, sir? But I will now show you. So we're going to use a couple of brackets. We need to do, for the top, we need to do 2 plus root 3 times 1 plus root 3. You need to expand those brackets. And then down here, we need to do the same thing for 1 take root 3 and 1 add root 3. So if we do this one over here and this one here, I could have 2 and root 3, 1 and root 3, 1 and negative root 3, and 1 and positive root 3. So you might want to pause the video and have a go before we go any further. 2 times 1 is 2, 1 times root 3, 2 times root 3 is 2 root 3, root 3 times root 3 is 3, 1 times 1 is 1, 1 times negative, so well, it's always going to be the same thing as it was if it's times by 1, root 3. Negative root 3 times root 3 is negative 3. So you do your root 3 times root 3 gives you 3, and you've got one negative, haven't you? And then we peanut our root 3's. And I can say that this up here is going to be 2 plus 2 root 3 plus another, that is 3 root 3. Oh, and I've got plus 3 there, haven't I? So I'm just going to cheat here at this point, and I'm going to say, all right, 2 plus 3, that makes 5. Let's put that in there. And then down here, 1 take 3. Well, that's going to be minus 2, so I'm going to put this bit afterwards. And what do we get when we do that plus that? Oh, they vanish, because it's difference between two squares going on. And so we've just got negative 2. So our answer for that is going to, if you divide a positive thing by a negative, it's negative. So it's going to be negative 5 plus 3 root 3 all over 2. So just 3 questions there. Last 3 things for today. Have a go at those, and I'll show you the answers in a moment. Pause the video. Okay, so here's our final answers. 2 minus root 2 over 2. Negative 3 plus 2 root 2, which you can write as negative 3 take 2 root 2. And the last one, negative 9 plus 4 root 2 over 7. Now, if you've ended up with the same answer, but you've got the minus 7 under here, that's understandable. That's what you'd get at first. But remember, if it's going to be rationalised, the denominator should be positive as well. So all you have to do is say, well, the answer of dividing something by a negative number is going to make it all negative. So you just stick the negative beforehand. But it's got to be right before that line. It can't be written as minus 9 over that, because then you think of that as a different thing. All of it is being taken away. It's as if there's some brackets around the whole thing, but we don't have to write them. Okay, well, I hope you enjoy. I know that got a little bit tricky towards the end, but hey, it's higher maths, folks. And so enjoy all of this. If you want to ask me any more questions, then please do, or Mrs. Hill, anytime you like. Okay, cheerio, folks.